The internet ran out of room 15 years ago. You just didn't notice. There was a ceremony. February 2011, Miami. Officials at a long table, flashbulbs, speeches, a press conference formatted like a funeral. What they were handing out that morning was the last of something the entire planet runs on, and when the ceremony ended, there was no more. Here's the strange part. Since that morning, billions of new devices have come online. Your phone, your TV, probably your doorbell. How do you keep filling a building that's already full? By the end of this video, you'll know who decided how big the internet could ever be. One man, in the 1970s, making a choice he thought was temporary. You'll learn why the story everyone tells about that choice, how could they be so short-sighted, gets it exactly backwards, and you'll find out why the fix we built for all this, a fix that's been ready since the 90s, is still stuck in traffic. 27 years later. Because this is a story about the most dangerous kind of decision there is. Not a bad one, a temporary one that worked. 90 seconds of basics, because the boring version hides the bomb. Every device on the internet needs an address, a number that says deliver the data here. No address, no existence, you can shout, but nothing can ever find you to answer. The internet's addressing system, IPv4, writes that number in 32 bits, 32 ones and zeros, which means the total number of possible addresses is fixed, 4.29 billion. It's not a quota or a policy or a price, it's arithmetic. The internet was born with a maximum occupancy sign. Therefore, the accusation writes itself. You'll find it in 1,000 forum threads. 4 billion? For the entire planet? How could the founders be so short-sighted? 8 billion humans? 20 billion devices? Obviously doomed from the start. Idiots, right? Except, run the numbers for the year the spec was signed. 1981. World population, about 4.5 billion. Computers connected to this network, a few hundred. The address space allowed nearly one address for every human being alive, for a network smaller than a high school. That's not short-sighted. That's absurdly, extravagantly oversized. So the real question isn't, why was the number so small? It's, if the number was that generous, what on earth was it for? It's the mid-1970s, in the research world around ARPA, the Pentagon's Advanced Projects Agency. A young computer scientist named Vint is working with Kahn on a genuinely wild problem, getting different kinds of networks to talk to each other. Radio networks, satellite links, wired computers, one common language across all of them. They call it TCP. And somewhere in that design work sits an unglamorous question: how many bits for the address? There are arguments. Some want longer addresses, some want variable length, room to grow. 32 bits wins. And here is the detail the forum threads never mention. It wins because this is an experiment, a demonstration, a proof of concept for a few dozen research machines. Cerf has said it plainly for decades. He thought there'd be a production redesign later, a grown-up version, with grown-up addressing, once the experiment proved the idea. 32 bits wasn't a forecast of the future. It was scaffolding. Therefore, September 1981, the design is written down as RFC 791, the spec that still runs your phone today, and then comes the date that turned scaffolding into skeleton. January 1st, 1983. The Flag Day. ARPANET by order because in 1983 one agency owns the network and can simply command it, switches every machine to TCP/IP on a single morning. A few hundred hosts, one paymaster, one cutover. It works. The experiment is now the network. And later, the production redesign, the grown-up addressing, quietly dies in its sleep. Nobody kills it. There's just never a morning when it makes sense to rebuild the ship because the ship keeps sailing. But here's where generosity becomes a problem, because when you believe you have infinite land, you don't sell it. You give it away. The early registry hands out addresses in blocks called Class A, 16.7 million addresses per block, to any large institution that asks. MIT gets one, Ford gets one, Xerox, IBM, Apple, one university sitting on more address space than most of the continents would later have. It's the land rush logic of people who think the frontier is endless. Therefore, by the early 1990s, as the internet goes public and starts doubling, the engineers run the projections and the projections come back wearing black. At current burn rate, the space is dead by the mid-90s, not the 2010s, the mid-90s. The response is a blur of emergency engineering. Compress it to one breath, smarter block sizes in 93 by-years, address conservation rules by more. Patches, good ones. But in 1994 comes the patch that changes everything. A modest little document proposing that many machines could hide behind a single address, with a translator at the door forwarding traffic in and out. Network Address Translation, NAT. And the authors are explicit about what it is: a short-term bridge, a tourniquet, something to hold until the real fix arrives. A short-term bridge, a tourniquet, something to hold until the real fix arrives. Remember that word, short-term. Because the patches worked. The 90s deadline slid to the 2000s, the 2000s into the 2010s. But arithmetic doesn't negotiate. The pool kept draining year after year until one Thursday morning in Miami. The counter hit 0. February 3, 2011. The global pool of unallocated addresses, the master supply, is formally exhausted. The last 5 blocks are handed out, one to each regional registry in that Miami ballroom, with speeches about the end of an era. Then the regions burn through their final reserves. North America runs dry in 2015. Europe allocates its last scrap in November 2019 and starts a waiting list for numbers. And yet, your doorbell got online in 2023 just fine. Billions of devices joined after the internet sold out. So now you can answer the cold opens question: how do you keep filling a full building? You stop giving tenants their own doors. Check your own router right now. The address probably starts with 192.168. That's not an internet address. It's a private one, from a reserved range set aside in the 90s, valid only inside your home. Your laptop, your TV, your phone on Wi-Fi, none of them are actually on the internet. They're behind a translator, NAT, the 1994 tourniquet, sharing one public address for the whole house. Your phone on cellular, worse, carriers stack another layer on top, and you're sharing one address with thousands of strangers. The temporary bridge became the building. And something profound broke, so quietly that almost nobody mourned it. The internet's founding idea, the reason it beat every rival network design, was that every machine is a peer. Any computer can reach any other directly. That's called the end-to-end principle, and it's why strangers could invent the web, email, file sharing, no permission needed, just 2 addresses and an idea. But a device behind NAT can dial out and never be dialed. It's not a peer, it's a customer knocking on server doors. The internet you use every day is not the internet that was designed. The design didn't survive. The illusion of it did. Meanwhile, the accusation, short-sighted engineers, collapses on contact with the record. The man who picked 32 bits picked it for a demo and has spent decades cheerfully taking the blame anyway. The real story is scarier than incompetence, a perfectly rational temporary decision, plus success, minus any moment when rebuilding was ever convenient. And scarcity did what scarcity does. It invented a market. Old Class A landlords cashing in. MIT sold millions of its addresses to Amazon. Cloud providers now charge rent for a public IPv4 address. Numbers, just numbers, with a price tag. You might be thinking, fine, but surely someone built the real fix eventually. They did, decades ago. And that's the strangest part of this whole story. 1998. The engineers finished the grown-up redesign at last, IPv6. Addresses 4 times longer, a space so vast it stops meaning anything, 340 undecillion, trillions of addresses for every human being, every device, every sensor, every light bulb a full pure again, forever. The end-to-end internet restored. It's finished, standardized, ready. That was 27 years ago. Today, IPv6 carries roughly half of traffic, depending on the day and the country. Half, after 27 years. The other half of the internet is still running the 1981 experiment behind 1994 tourniquets. Why? Look back at 1983. The Flag Day worked because someone owned the network. One agency, a few hundred machines, an order given and obeyed. Nobody owns today's internet. There is no one to order 2 billion households, 20,000 operators, and every piece of software on Earth to jump together. Worse, IPv6 isn't backward compatible. An IPv6 only machine can't reach the IPv4 world, so everyone must run both indefinitely, paying double for a benefit users can't see. But the deepest reason is the cruelest, and it rhymes with everything you've watched. NAT, the tourniquet, removed the pain. The crisis that should have forced migration became survivable, comfortable even. The workaround didn't just delay the cure. The workaround is why the cure can't finish. 15 years after the internet ran out of room, the old address space isn't retiring, it's appreciating. Last episode, the 19-inch rack taught one flavor of lock-in, a decision with no author can't be appealed. This story teaches a darker one. Nothing is more permanent than a temporary fix that works. Because a working workaround doesn't just patch the problem, it dissolves the urgency, and urgency was the only force strong enough to fund the real repair. Every system you touch is full of this. The interim process at work entering its 9th year, the Toto comment older than the intern reading it, the spreadsheet that was going to be replaced by real software in 2019. Each one survived by the same mechanism as NAT. It worked just well enough to make the redesign optional. And optional, at scale, means never. So here's the lens to keep when someone says temporary. Ask what happens if it succeeds. The failures clean themselves up. It's the successes you'll be living inside in 40 years. So, the internet ran out of room 15 years ago and you didn't notice because the internet learned to sublet. A ceiling chosen for an experiment, a patch that ate the design, a cure stuck behind its own workaround. That's how big the internet is allowed to be. But an internet with no room left still needs somewhere to live, physically, buildings, power, land. And it turns out that half of it, by some measures, most of the world's traffic, lives in one county in Virginia, not because anyone chose it, because of a Cold War network, a parking garage handshake in the 1990s, and the same force that ran through this whole story, whatever lands first, wins. That's next time on Load-Bearing History. Consider liking and subscribing for more load-bearing history videos.